All right, so in today's video, you're going to be able to substitute x in one function with another function in order to create a composite function. So before we start, I want to talk about this vocabulary so you make sure you understand what I'm saying when I use these words, okay? So the first word I want to talk about is substitute, all right? What does it mean to substitute something? To substitute something, it means you're going to replace with something different, okay? So that's what we're going to do. We're going to be taking one function's x and replacing it with something different. That is what we mean when we're talking about substitute, all right? A function, what is a function? Okay, so that word function, what does it mean? It means the set of x, which is your input, okay, to a set of y's, which is your outputs, okay? So a function is just where you have a set of inputs, things you put into x, and you have a set of y's and outputs, which you get once you input something, okay? So a function is just a set of inputs to a set of outputs, okay? And then the newest word that we have is composite. What does composite mean? Okay, composite means that it is made up of various parts or elements. And that is so awesome because I like that definition because that's what we're doing. We are taking a function, we're creating a new function that is made of two functions inside of each other. So it is made up of various parts. So we're making a composite function that is made up of two functions, okay? All right, so we're going to do some examples, okay? We're going to do some more in-depth examples where you're going to have to square your quantities, okay? I wanted to spend a whole day on this because the biggest mistake people make here is they forget to do quantity squared. Okay, and I'm going to show you what I mean by that, okay? So we're just going to do it, we're going to start with example 1, okay? And I'm going to give you f of x equals 3x squared minus 4x minus 1. And then I'm going to give you g of x, which is negative 2x plus 5, okay? And I want to find f composite g of x, okay? So we've already talked about a little bit of this, all right? But I want to go into depth what it means to be a quantity squared, okay? So what this f composite g means, or as y'all say, FOG, it means f of g of x. That means I'm going to take the g function and I'm going to plug it into the f function. That's where the substitute is coming from. I'm going to substitute all of f's x's for this g function. Okay? That is what I'm going to do. So, let's do it. So we're going to say 3. When we get to an x, you're going to replace it with g, which is negative 2x plus 5. Don't forget the squared. Minus 4, I came to another x, so let's replace it with g function, substitute, and then minus 1, okay? The biggest mistake you're going to make is right here with the squared, okay? That squared, go over here to a side note, the negative 2x plus 5, the negative 2x plus 5 squared means there are 2 of them, okay? And what do you do when you have 2 binomials? You learn this in math too. When you have 2 binomials, you're going to use double distribution, okay? And we'll use the box method, okay? So when you have a quantity squared, you have to use the box method. So we're going to say negative 2x plus 5 right here. Negative 2x plus 5. Okay, you should be remembering this. So negative 2x times negative 2x is positive 4x squared. 5 times negative 2x is negative 10x. Negative 2x times 5 is negative 10x again. And then 5 times 5 is 25. Then we pull out our stuff, which will be 4x squared minus 10x plus 25. Combine your like terms, and you have 4x squared minus 20x plus 25. So I now can replace this quantity squared with this. So I have 3 parentheses 4x squared minus 20x plus 25 minus 4. It's negative 2x plus 5 minus 1. Okay? All right. Next, you get to what we remember. Anytime there's a number on the outside of the parentheses, we distribute that number. So I'm going to distribute 3 to everybody in that parentheses. Okay? And I'm going to get 12x squared minus 60x plus 75. I get to the negative 4. Let's distribute that. That's going to be plus 8x minus 20 minus 1. After you do that, you're just cleaning up house. Combine your like terms. 12x squared has nobody alike, so we just bring it down. The negative 60 and the 8x can be combined. Okay, so I'm going to say negative 60, just so I get it right. Negative 60 plus 8. I get negative 52x. And then I have 75, negative 20, negative 1. And I get 54. And guess what, guys? That is your new composite function. That is the function that is made up of various elements, which the elements were f of x and g of x. Okay? All right. We're going to do some more. Okay? All right. Next one. Well, let's do a little, I meant to start with a simpler one, so let's do a simpler one and then do some more hard ones, okay? So I'm going to give you h of x equals x minus 1 and g of x equals x squared. No, wrong one. Let's save that one. My bad. Let's do this one. F of x equals x squared plus 7 and g of x equals x minus 3, and I want to find f of g of x. Okay? Alright, so it's already written the way I want it to be written. Okay? So it is telling me that I want to take g of x and I want to substitute it in to f of x. So I want to take this g of x function right here and I want to substitute x. I want to substitute, let's erase that. I want to substitute, how many times can I say that word in 2 seconds? That x with that, okay? So, that's what I'm going to do. I want to take this x and substitute it for x minus 3. So now I'm going to have x minus 3 squared plus 7, because there was only one x to substitute, so that's all I did. Now, this is a quantity squared, so this really means x minus 3 times x minus 3 plus 7. That exponent just tells you how many times to write it. If that exponent was a 3, we would write that 3 times, okay? Now, in order to multiply these, you either do double distribution. I like the box method, okay? So I'm going to come over here to the box method. Most of y'all use it, so that's why I stick to it. And I prefer it most of the time. So x times x is x squared. Negative 3 times x is negative 3x. That's another negative 3x. And then negative 3 times negative 3 is 9. Pull out your stuff. X squared minus 3x plus 9. Combine that middle term. And I'm going to have x squared minus 6x plus 9. So now I know that these two multiplied together equal this. So I can write that. X squared minus 6x plus 9 plus 7. And after you do that, it's nothing but cleaning up some house. So x squared doesn't have anybody and 6x doesn't. But the 9 and the 7 can be combined to give you plus 16. And that is your answer. That is your composite function. Okay? All right. Now let's do another one similar to that, okay? All right. Sometimes I think my computer has a mind of its own. It does, but I think it needs to calm down. So let's do this one. H of x equals x squared plus 1, and f of x equals 2x plus 1, okay? And I want to find h composite f of x, okay? Now, this is written the way we don't like it, so this right here, all it means is I want to find h of f of x. So that means I'm going to take the f of x function and substitute it into h of x. So I'm going to take this function and substitute it over here. So now I have quantity squared of 2x plus 1 and then plus 1 on the outside. That squared means to write that quantity twice. Okay, this needs to be multiplied out, so we're going to come over to the side and show our work. And I'm going to have 4x squared and then 2x and then 2x and then 1. Pull your stuff out. 4x squared plus 4x plus 1. Oh, I did it all in my head. My bad, guys. I got a little excited there. Sorry. Pull out what you got. Then combine your like terms. But you can skip that step, but I'm trying to show you it all. So it's going to be 4x squared plus 4x plus 1. So I now know that this multiplied out gives me 4x squared plus 4x plus 1. Drop down the plus 1. I can't combine 4x squared with anything. I can't combine 4x with anything. But I can combine the 1 and the 1 and get 2. So my final answer is 4x squared plus 4x plus 2. Okay? And this is exactly what your assignment's on today. Okay? It's doing nothing but quantity squares. Okay? All right. We got 3 more examples we're going to do. Let's do another one substitution, and then we'll do 2 more that has 2 substitutions in it. Okay? All right. So the next one is going to be g of x equals 2x squared minus 8, and f of x equals negative 3x plus 7, and I want to find g of f of x. Okay? All right. So let's go do this color. Okay, so this is where I'm going to take the f of x function and I'm going to substitute it into the g of x function. I'm replacing that x with negative 3x plus 7. Okay, so I've got 2 times negative 3x plus 7 squared and then the minus 8. That squared means that there are 2 of those parentheses. Okay. And now I need to box these out or double distribute, whichever one you prefer. Okay. So I'm going to box them out. Negative 3x and 7. I get 9x squared. That's a negative 21x, negative 21x. And that's going to be a 49. Pull your stuff out. Combine your like terms, which will be the 21x's. And then we'll have 9x squared minus 42x plus 49. So I now can replace those 2 quantities. I can't get rid of the parentheses because I have that 2 on the outside. Okay? 9x squared minus 42x plus 49. Do you see that I handled the multiplying before I handled the distribution? Okay? It's kind of like handling what's inside your parentheses first and then distribute. Okay? You will distribute after you pull your stuff out. Okay? Now I can distribute that too and get 18x squared minus 84x plus 98, and then bring down your minus 8. Okay? And the only thing that I can combine here are these last 2 numbers. So I have 18x squared minus 84x, and that's going to be a plus 90. And that is your final answer. That is your composite function. Okay? All right. 2 more left. Okay? All right. So let's slide it over like this. All right. So we're going to have h of x is equal to x minus 1. G of x is equal to x squared plus 2x minus 8. And I want to find g of h of x. Okay? So this is where I'm going to take the h function. Okay, I'm going to take this h function and I'm going to substitute it into my g function. But I have 2 x's here, so I'm going to substitute twice. And you're noticing when I substitute, my stuff's in parentheses. You know how I like my parentheses. Helps you not make as many mistakes with parentheses, in my opinion. Okay? So let's start substituting. I come across an x, so I'm going to say x minus 1 squared plus 2, substitute, x minus 1 minus 8. This squared means I have 2 of these guys. Okay? So I need to full these out. Okay? I'm going to come over to the side and I'm going to full them out. X minus 1, x minus 1. You can put negative 1x if it makes you happy. We'll do it. And then 1, you bring the stuff down, x squared minus 1x plus 1. Combine that middle term, x squared minus 2x plus 1. So now I can replace this, x squared minus 2x plus 1. What can I do with this 2? I can distribute it. When I'll get 2x minus 2 minus 8. Now clean it up. There's no other x squared, so I drop it down. That's a positive 2x and that's a negative 2x and a positive 2x. What happens with those 2 x's? A negative 2x plus a positive 2x, they cancel out. So then I just have 1 minus 2 minus 8. So 1 minus 2 minus 8 is going to give you negative 9. And I just have x squared minus 9 is your final answer. Okay? All right, last problem I'm going to do, unless you request more, okay? All right, this one is going to be f of x is equal to negative 2x plus 5, and g of x is equal to x squared plus x plus 10. I'm actually going to do this one both ways, okay? I'm going to split it down the middle here. Okay, because I want you to know that your delta math is not always going to be squaring. So I want to actually do f of g of x, and I want to do g of f of x. Okay? All right. So the one on the left hand side, okay, it wants me to take g and put it into f. So over here, I'm going to take g and I'm going to plug it into f. Okay? So negative, substitute, x squared plus x plus 10, and then bring down your plus 5. Do I have anything here to quantity squared? I don't. Okay, so I don't have to do that side work. But I do need to distribute this negative 2, and I get negative 2x squared minus 2x minus 20, and then bring down the plus 5. The only thing I can combine is the n down there. So my final answer is negative 2x squared minus 2x minus 15. Okay? And that's your final answer there. All right? So see, it just depends on which way you're going to the work you have to do. Okay? Because you're going to see both on Delta Math. All right? So if there's not a quantity square, you don't do it. Now on the next one, when I do it the other way, it wants me to take f of x and plug it into g of x. So now I'm going to take f of x and substitute g of x. with that, okay? So substitute negative 2x plus 5 squared plus negative 2x plus 5 and then plus 10. This squared means there's 2 of them. Do I need these parentheses for that second x? Is there anything to distribute there? No, there's not. So I don't need it. And I'm just going to have minus 2x plus 5 plus 10. Okay? I need to box these two in. Okay? So I'm going to come over here on the bottom and I'm going to box them in. Get 4x squared, negative 10x, 25. So that's going to give me 4x squared minus 10x plus 25, which cleaned up is 4x squared minus 20x plus 25. All right. So now I can replace that with 4x squared minus 20x plus 25, and then bring down everything else. Now just combine your like terms. Clean it up. Okay, so I can bring down the 4x squared. I've got a negative 20x, a negative 2x, which would be minus 22x. I've got a positive 25, a positive 5, and a positive 10, which is going to be a 40. And that is your answer. But do you see how they're different functions? They're different composite functions because you did them differently. Okay? Now sometimes they'll be the same, but that's very rare. So I hope this helps. Go ahead and log on to Delta Math, do your assignment. If you need more problems and more examples, just email me or log on to Zoom during the class period. All right, guys.